For decades, the moon felt like a closed chapter in human history. In the 1960s and early 1970s, the Apollo missions placed 12 astronauts on the lunar surface. They collected rocks, planted flags, and proved that humans could walk on another world. And then, we stopped. For nearly 50 years, the moon became a place humanity visited once and left behind. But suddenly, something has changed. China keeps going back. Orbiters, rovers, sample return missions, and now, plans to send astronauts. At first glance, it looks like a new space race. But the real reason is much bigger than competition. China isn't just exploring the moon. They're preparing to use it. China's return to the moon didn't happen overnight. It began with a long-term strategy known as the Chinese Lunar Exploration Program, a step-by-step roadmap. First, orbit the moon. Second, land robotic explorers. Third, bring samples back to Earth. And finally, build the technology needed for a permanent human presence. Each step builds on the last. In 2007, China launched its first mission, Chang'e 1, named after the moon goddess of Chinese mythology. It became China's first lunar orbiter, mapping the surface in detail. 3 years later, in 2010, came Chang'e 2. It created even higher resolution maps, helping scientists identify potential landing sites. These missions didn't make global headlines, but they did something critical. They gave China the most detailed maps of the moon it had ever had. Then came the breakthrough. In 2013, Chang'e 3 successfully landed on the moon. For the first time in nearly 40 years since Apollo, a spacecraft was operating on the lunar surface again. It carried a small rover called U2, or Jade Rabbit, and almost immediately, it found something unexpected. As U2 explored the surface, it analyzed the composition of rocks and soil. Some of the rocks were basalt, formed from ancient lava flows, but they didn't match the samples collected during the Apollo missions. They were different. Their chemical composition suggested something surprising. Parts of the moon had formed through different volcanic processes than scientists previously believed. This changed everything. For decades, most of what we knew about the moon came from a handful of Apollo landing sites, all located on the near side. Chang'e 3 revealed that those samples told only a small part of the story. Large portions of the moon remain unexplored, and they may hold entirely new types of material, but that was only the beginning. In 2019, China did something no one had ever done before. Chang'e 4 became the first spacecraft in history to land on the far side of the moon, the side that never faces Earth. This was a huge challenge, because once a spacecraft lands there, it loses direct communication with Earth. China solved this by launching a relay satellite called Chang'e. It allowed signals to bounce between the far side and Earth. With that connection in place, Chang'e 4 landed successfully inside the South Pole Aitken Basin, one of the largest impact craters in the entire solar system. Scientists believe this region may expose material from deep inside the moon. Then came another major step, Chang'e 6, a mission designed to bring samples back from the far side of the moon, something never done before. And it succeeded, returning around 2 kilograms of lunar soil and rock. Early analysis revealed something remarkable. These rocks formed around 2.8 billion years ago. That's important, because it challenges what we thought we knew. It suggests the moon may have remained volcanically active much longer than expected. In other words, the moon's history is far more complex than we imagined. But even these discoveries are not the main goal. China's real target lies somewhere else, the lunar South Pole. At first glance, it looks like one of the harshest places imaginable. Towering mountains, deep craters and regions that have never seen sunlight for billions of years. Temperatures there can drop below -200 degrees Celsius, colder than almost anywhere in the solar system. But those extreme conditions may have created something incredibly valuable: water. Frozen water ice, trapped in permanently shadowed craters. And water on the moon changes everything, because water can be split into two key elements: oxygen for breathing and hydrogen, one of the most powerful rocket fuels. If these resources exist in large amounts, the moon could become something revolutionary, not just a destination, but a fuel station in space. Future spacecraft wouldn't need to carry all their fuel from Earth. They could refuel on the moon and then continue deeper into space, to Mars and beyond. This is why China's next mission, Chang'e 7, is so important. Its goal is simple: find water. The mission will include multiple components: an orbiter, a lander, a rover, and a unique hopping probe. This probe can jump into deep, shadowed craters, places where sunlight never reaches, where traditional rovers cannot survive. Inside those dark regions, it will search for signs of water ice, hydrogen, frozen deposits. If it succeeds, it could confirm, once and for all, that usable water exists on the moon. But finding resources is only the first step. The real challenge is using them. That's where Chang'e 8 comes in. Planned for around 2028, its mission is to test how humans can build on the moon, using local materials. This concept is called ISRU, in situ resource utilization. Instead of bringing everything from Earth, use what's already there. Robots may melt lunar soil to create solid building blocks. 3D printing could be used to construct structures. Oxygen and water might be extracted directly from the soil. Autonomous systems could build roads, landing pads, and shelters before humans even arrive. If this works, it proves something incredible. Humans don't just have to visit the moon. We can build on it. And once that becomes possible, the next step is inevitable: humans return. China is now developing the systems needed to send astronauts to the moon. At the center of this effort is a new rocket, Long March 10. The mission will involve 2 launches, one carrying the spacecraft, the other carrying the lunar lander. They will dock in lunar orbit. Then, 2 astronauts will descend to the surface. They will conduct experiments, collect samples, and test technologies for long-term missions. These early missions may be short, just hours or days, but they are only the beginning, because China isn't trying to repeat Apollo. They are building towards something much bigger: a permanent presence. This vision is called the International Lunar Research Station, or ILRS. Announced in 2021, it is one of the most ambitious space projects ever planned. A base on the moon, located at the South Pole, where water ice may exist. The station will not appear overnight. It will be built step by step. In the early 2030s, robotic missions will begin construction, delivering equipment, power systems, communication networks, laboratories. Robots will do most of the early work, preparing the site before humans arrive. At first, it will operate as a robotic research station, but over time, it will support human crews, astronauts living and working on the moon for extended periods. China is also inviting other countries to join, positioning the station as an international effort. If successful, it would mark something humanity has never achieved before: a permanent foothold on another world. And that changes everything, because the moon is more than just a scientific destination. It has real strategic value. Its gravity is only 1/6 of Earth's. Launching spacecraft from the moon requires far less energy. If fuel can be produced there, the moon becomes a gateway to the solar system. It could serve as a launch platform, a refueling station, even a hub for deep space exploration. The far side of the moon also offers a unique advantage. It is shielded from Earth's radio signals, making it one of the quietest places in the solar system, perfect for powerful telescopes. All of this leads to one conclusion. Whoever builds sustainable infrastructure on the moon will have a major advantage in the future of space exploration, which explains why China is investing so heavily. But even now, the moon still holds many mysteries. China keeps returning for 3 reasons: scientific discovery, strategic resources, and long-term human presence, because the moon may become humanity's first true home beyond Earth. And if these plans succeed, the next chapter of human civilization may not begin on Earth. It may begin on the moon.